Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Azaliza binti Adil Wahab and I am from class AS1213A.
Hi, my name is Anzulaika binti Alias and I am from AS1213A.
My name is Safizatara Aida binti Matsuki. I am from AS1213A.
Assalamualaikum warahmatullahi wabarakatuh. My name is Fazil Amiza binti Zainuddin from AS1213A.
Assalamualaikum warahmatullahi wabarakatuh. First of all, I would like to say thank you to our lecturer, Serafi Rahman, for giving us opportunities to present our experiment for Lab 6, which is gas chromatography. And our group consists of 4 members, which is Fazil Amiza, Anis Zulaika, Hafizatul Aida, and myself, Nur Azaliza binti Abdul Wahab. The title for our presentation today is Gas Chromatography Mass Spectrometry. So things that will be included in this presentation, for number 1 is introduction and objective, number 2 methodology, number 3 result analysis, and number 4 conclusion. The objective for the experiment today is to identify the separated components of peppermint oil and lavender oil, and number 2 is to identify specific ions in the spectra that will be used for qualitative analysis. So for introduction, essential oil is a compound that comes from certain parts of plants such as leaves, herbs, and more. It is a highly concentrated extract and containing volatile chemical compounds. To get an essential oil, usually it will use the distillation process via steam or water, or can be both, or also by mechanical method, which is cold pressing. The essential oil can be volatile because it contains 1 or 200 different carbon and hydrogen base compound, which is easy to be evaporated at normal temperature and extremely flammable. Peppermint and lavender are top 2 in the list of popular essential oil that the health has claimed. Generally, peppermint oil is used to boost energy and aid digestion, while the lavender oil is mostly used for stress reliever. So in this experiment, we will use the gas chromatography, which is GC method, to identify the separated components of essential oils and analyze the non-polar compounds in a mixture that is reasonably volatile and thermally stable. The basic principles of gas chromatography, which is the separation, is based on different distribution of molecules of the components between mobile phase and stationary phase. The GC mass spectrometry is used as the detector for the gas chromatography. It can detect the amount of chemical in a small quantity such as picogram. It can be used to analyze the volatile molecule, but it doesn't have enough capability to directly analyzing the non-volatile, polar, and thermally sensitive compounds. A different scan method are used to improve the quantitative analysis, such as selected ion monitoring, which is SIM, and GCMS-MS, which is stand for gas chromatography mass spectrometry and gas chromatography tandem mass spectrometry. It is because it has a greater sensitivity and specificity. The GCMS-MS has a capability of isolating and fragmenting a molecular weight, and the result can be analyzed with mass spectrometry. The SIM will focus on certain ions that are recorded continuously rather than operated in the normal mode of scanning, and in its sensitive mode, one ion is monitored for the duration of the experiment.
Next, for the apparatus are variant 320MS triple quadruple mass spectrophotometer and variant CP3800 Bruker gas chromatography. For the chemicals are lavender essential oil, peppermint essential oil, linalool, and trans-caryophyllene. Next, the method. There are 2 segments for the method of this experiment. First one is quality analysis of the peppermint and lavender essential oil using GCMS. Firstly, sample of lavender and peppermint essential oil were diluted in ratio 1:100 in absolute ethanol. Then, using the variant software, automated injection was performed. Thus, the chromatogram of the solution was measured and recorded in the table. The second one is determination of concentration of caryophyllene and linalool in oils by using GCMS, MS, and GC-SIMS. The sample of lavender and peppermint oil were diluted in ratio 1:100 in the absolute alcohol. Thus, the dilution of linalool and caryophyllene was prepared in the concentration of 1:100, 1:200, 1:400, and 1:800. Then, using variant software, automated injection was performed for each solution. Lastly, the chromatogram of the solution was measured and recorded.
Assalamualaikum warahmatullahi wabarakatuh. I'm Fazri Amiza binti Zainuddin. In this experiment, I will discuss about the analysis. So in this analysis, we will get the result of the retention time of peppermint and lavender. So for the table 1, this table shows that the retention time for the identified compound of peppermint and lavender oil by GCMS in full scan mode. So in this table, we will get the value of peppermint and lavender. Okay, so for the caryophyllene, we get the value of peppermint and lavender, which is 16.725 and 16.720. For the linalool, we get 11.822, and lavender, we get the same value. For the puleguen, we get 14.121 and also same value. For the ladle, we get 18.915 and also 18.915. For methyl acetate, we get 14.597, and for both peppermint and lavender, we get the same value. And for the minfuranon, we get 70.713, and also this in this value, we also get the same value. And for the limonene, for peppermint, we get 10.459, and for the lavender, we get 8.088. And for the menthol, we get the 13.153, and for the lavender, we get also the same value. But for the mentofurane, for peppermint, we doesn't get any value, but for the in lavender, we get 17.713. And for the eucalyptol in peppermint, we get 10.503, and in lavender, we get 10.518. And for 1,2, dihydronibal, we get 12.355, but for the lavender, we doesn't get any value. And also for the acetophen and heptacillosine, they doesn't have any value for lavender, but they have a value for peppermint, which is 8.863 for acetophen, 24.832 and 21.151 for the heptacillosine. Okay, for the table 2, we will get we use this information in the table to find the value of caryophyllene concentration in the sample and also caryophyllene concentration in the oil. So this table is show the relationship between the peak area and caryophyllene concentration in sample and oil by GCMS-MS. So for the peak area in peppermint oil is 497,255, and for lavender oil is 456,756. Okay, for the caryophyllene concentration, to find the caryophyllene concentration in oil, we must find the value of caryophyllene concentration in the sample first. Okay, so we just substitute the value of peak area into the equation that already given in the article, which is y equal to 3 exponent 8s. So the value of y for peppermint oil is 497,255. So we divide with 3 exponent 8, we will get 0.00166. Okay, so for this value, we must multiply with 100, because we dilute the solution 100 times in alcohol, so we will get 0.166. Okay, for the caryophyllene concentration in lavender oil, we will use the same step as as we want to find the value in peppermint oil. So for this lavender oil, y equal to 3 exponent 8s. Just substitute the peak area, which is 456756, equal to 3 exponent 8s. We just divide, and then we will get the value of x is 0.00152. So with this, we will dilute the solution 100 times with alcohol. So we need to multiply the value of x with 100, so we will get 0.152, and the value of 0.152 is the value of the cryophyllene concentration in oil for lavender oil. Okay, for the table 3, this table 3 show the relationship between peak area and linalool concentration in sample and oil by GCMS-MS. So for the peppermint and lavender, we get the peak area, which is 101374, and for the lavender we got 2.967 exponent 5. So for this two value, we will get the X, and also we will get the value of concentration in oil. Okay, to find the peppermint oil concentration in sample, we just substitute the value, which is this y equal to 1 exponent 8x. This equation already given. Okay, so for the value of y is 101374, so divide with 1 exponent 8x, so we will get the value of x is 0.0010. Since we dilute this in solution in 1:100 in alcohol, so we need to multiply with 100. Okay, so 0.0010 times with 100, we get 0.10. So 0.10 is the value for the concentration in oil, which is in peppermint oil. Okay, next, to find the linalool concentration in sample in lavender oil, first y equal to 1 exponent 8x, substitute the peak area, which is 2.967 exponent 5, so we get the value of x is 0.00297. Since we dilute in 1:100 in alcohol, so we need to multiply the obtained concentration in linalool to 100, so we will get 0.297, which is this is the value for linalool concentration in oil. Okay, for the table 4 is show the relationship between peak area and cryophyllene concentration in sample and oil by GCMS and SIM. Okay, in this table, we get the peak area for the peppermint is 1.503 exponent 7, and the value of concentration in sample is 0.00167, and in oil is 0.167. And for the lavender, we will get 1.259 exponent 6, and in sample we get 0.00139, and in oil we get 0.139. So to get the value of concentration in sample and concentration in oil, we just substitute the peak area in y, and we will get the value of x, and for the value of x is a value of concentration in the sample, and then we need to multiply with 100, and we will get the value of concentration in oil in both, which is lavender and peppermint. Okay, lastly, for the table 5 is show the relationship between peak area and linalool concentration in sample and oil by GCMS and SIM. Okay, to get this value, we must do the same step as table 1, table 2, table 3, and table 4. So for the peak area, we get the 807460. And linalool concentration in sample, we get 0.0018, and in oil we get 0.018. So to get the in both value, which is concentration and sample in oil, and in oil, we just substitute the value peak area in y, and we divide with the equation, and we will get the value of x, and we must multiply with 100. Why we need to multiply with 100? Because we dilute the solution that we use with 100 times with alcohol. So that's why we need to multiply with 100.
Hi, Assalamualaikum. My name is Anis Zulaika binti Alias and I will presenting about the discussion that we get from the experiment. So, from table 1, it will show that we successfully identified 12 of the components in the sample of peppermint and 10 in the sample of lavender essential oil. The result is also similar as the studies that was conducted by Shelley in 2002, which also found the component of limonene, polygon and menthol using gas chromatography, mass spectrometry. So it also similar with the studies that was conducted by Beja in 2008, which also found limonene, menthol and linalool in peppermint essential oil. Even though we managed to get the result, there's also some component that cannot be characterized because it is not sufficiently accurate mass spectra was achieved. It was further resolved in the solvent. Also, the correction of the background that was loose and degraded the spectral quality. The retention time of the minor character is similar to the prominent component, so the minor character cannot be characterized. Next, in figures 1 to 4 shows that standard curve of quantitative analysis of the lavender and peppermint essential oil. The quantitation was performed by using triple quadruple mass spectrometry. Although gas chromatography mass spectrometry is used to obtain quantitative sample, it also have a response factor which differs significance for various analyses but not for multi-component sample. SIM also allows a high sensitivity in detecting particular component. The device adjusts to collect masses of interest of 69 for caryophyllene and 76.9 for linalool. This SIM will gather only based on selected mass fragment, which is the interest compound. The more mass was detected, the more time needed to look into the mass, and also it will increase the sensitivity for the SIM. It also allows accurate and precise quantitative result. Also, a standard curve was plotted to measure the concentration of the substance of the interest, which is in this case is caryophyllene and linalool. By extrapolating the curve, and the concentration will be successfully be determined. This shows that MSMS and SIM method can be used in quantitative measurement, and it also shows that SIM method is more accurate than MSMS method. This is because the higher the slope of standard curve, the higher the sensitivity of the method. For conclusion, we successfully determined the component in lavender and peppermint oil by proving that there is 11 of the substance in each of it by using gas chromatography. We also proved that GSMS analysis discloses a clearer indication of molecular complexity in the essential oil. We also done quantitative analysis by using gas chromatography with MS and SIM modes, which shows that SIM modes is accurate than GSMSMS. That's all from us.